Welcome to DevOps Toolkit, the channel where composing resources is the path to internal developer platforms. Whomever is building developer platforms, probably you, is bound to come to the conclusion that there is a need to compose resources and expose those compositions through APIs. If a developer needs a database, they should be able to specify what that database should be without having to deal with subnets, VPCs, internet gateways, and other low-level components that are required but are not important for the vast majority of people who just want a database. We are likely to come to a similar conclusion if, for example, a developer wants to run an application. That developer might want to specify a container image, a port, and a host without having to worry about Kubernetes deployment, services, ingresses, scalers, virtual services, and other lower-level Kubernetes types of objects. So we need a way to create new API endpoints that will represent the right level of abstraction and that will, at the same time, compose lower-level resources based on higher-level resources created through those endpoints. All of us, people trying to enable developers to be self-sufficient, need something like that, me included. That's why I was very, and I repeat, very excited when I discovered a new project called CRO. It allows us to enable developers to define something like this. When those 10 or so lines of YAML are applied, we would get something like this. That simple manifest resulted in a creation of a deployment, a service, and an ingress. Each of those alone would require more work than that single application manifest, and that was a simple example. If we added a database to the mix, benefits would be even greater. If we expanded it to infrastructure, oh boy, we would get even more. So, what is CRO? CRO allows us to create abstractions that encapsulate Kubernetes resources. What that means is that CRO enables us to create new API endpoints in Kubernetes clusters and define which resources will be created when someone creates resources based on those new endpoints. It simplifies creations of custom resource definitions and controllers. The idea is awesome, yet somehow familiar, right? Based on that description, you can think of CRO as a tool that serves a similar purpose as KubeVela or Crossplane, or specifically Crossplane compositions. As a matter of fact, when I heard about CRO, the first thought that passed through my head was, hey, this is very similar to Crossplane compositions. Is this going to replace it? Should I give up on Crossplane now that there is a new project that does something similar? It must be, and I repeat, it must be better than Crossplane compositions. Otherwise, why would they start a project like that? So, today's day will not only explore CRO, but also see whether it is time for me to give up on Crossplane. I do not want to stay with a project that gets superseded by some other. So, depending on how this goes, this might be my last day working on Crossplane. All in all, there are two questions we'll try to answer, or I'll try to answer. What is CRO, and if applicable, is it a Crossplane compositions killer? Now, before we proceed, let me state that I'm involved in the Crossplane project. As such, you might think that this video is dishonest. I do my best to always give an honest opinion based on experience and never to say it depends, no matter whether I'm talking about a project I use or a project I work on, or both. Still, the truth is that I'm actively involved with Crossplane, and it's up to you to decide whether that makes me dishonest in what I'm about to say. It's up to you. Okay. Let's do it. Let's go. Here's the definition of an app I would like to convert to a CRD and a controller with CRO. There is nothing special about it. It is a relatively simple set of manifests that should result in an application and a database running inside the Kubernetes cluster. What I want is to convert it into a new CRD called application that people should be able to use to create instances of their applications without having to worry about deployment, services, ingresses, PostgreSQL, database schemas, and whichever other low-level details are required to run stuff in Kubernetes. They should focus on what they need to do rather than how to do it. I expect people to be able to specify only the things that matter to them and not much more. Everything else should be implementation details. In that spirit, I would want them to be able to set a name of the application, container image, including release tag, and a port the application is exposing. Further on, there should be an optional ingress, since not all apps need to be exposed to the outside world. If ingress is enabled, they should be able to specify the host. They should also be able to optionally have a PostgreSQL cluster, and if they do, they should be able to specify SQL schema. All those pieces of information are already available in the raw manifests. The problem is that everything else is noise. Now, I could wrap it all up into, let's say, a Helm chart and instruct everyone to only manage the values file. That's silly. We are way past that. By now, we should be aware of the benefits of using APIs to expose services as opposed to giving people random files and instructions what to touch and what to keep intact. There are many benefits to exposing services through APIs, and I will not go through them today. I already covered it in quite a few times in this channel. What matters is that we will use CRO to create a custom resource definition, or CRD, with the schema we discussed, and to compose the low-level resources whenever someone creates or updates a custom resource. Now that we know what we're trying to accomplish, let's just do it, step by step. CRO comes with a CRD called ResourceGroup that allows us to define a schema which will ultimately become a Kubernetes CRD, as well as a list of resources that should be composed whenever someone creates or updates a custom resource based on that CRD. Now, that was handful, I admit, but we'll see it in action in a second. So, we'll start easy by trying to define a part of the schema for the CRD and compose only the deployment and the service. If that works out, we'll progress towards additional resources and maybe, just maybe, a more complicated setup. Here's the first iteration of the resource group. We are defining a resource group with a schema. That schema will eventually become a CRD. We can think of it as a simplified way to define a CRD. There is the API version and the kind of that future CRD, as well as the spec. Now, bear in mind that we can have anything as the schema kind. In this example, it is application, but in yours, it could be database or cluster or unicorn or rainbow. You're in charge of what the name as well as the schema of your CRDs will be. Further on, we are defining that we would like the spec of the CRD to contain fields name, image, tag, and port. They should be self-explanatory, right? You know what those are. Each of those has a mandatory type of the field, like string and integer. If we need to define additional properties, we can do that by adding pipe after the type and write whichever property we would like to have. For now, the only one we are using is the default value of the port, which we are setting to 8080. As a result of that schema, people should be able to define custom resources of the kind application with mandatory fields name, image, and tag, and the optional field port, which, if not set, will default to 80,000. What we saw so far is awesome. I love it. That was maybe the easiest way to define a CRD I've seen among any of the tools. Now we're going to the next part, and that's resources. They are an array that defines templates CRO will use to assemble the resources. For now, we're focusing on deployments and services. So we have a resource with the ID deployment and a template that I copied from the original definition we saw earlier and then modified to make some values dynamic. Those values are defined using self, or common expression language, which is gaining traction lately, especially since it became the language used by Kubernetes validating admission policies. It's fairly simple. We are putting the value of future custom resources. There are the spec name, spec image, spec port, and so on and so forth. The same logic is repeated with the service. So far, I must say that I'm loving it. CRO resource groups are very, very simple to define. The syntax is easy and there is no boiler code. It's beautiful. It's truly beautiful. Now, let's see whether it works by applying the resource group we explored and retrieving resource groups. It's nice that it shows which resources will be assembled in the topological order column. I suspect that will become a mess if we start having 10 or more, but for now, it's great that we are able to easily deduce what will be assembled. If everything worked as expected, we should have gotten a new CRD applications. So let's confirm that. It's there, and I'm happy. I'm truly happy. Finally, let's see whether we can create custom resources based on that same CRD. Here's an example. That's the experience I was looking for. There is no need to waste time defining deployments and services when we can focus only on the data that matters. In this case, we defined the name, the image, and the tag as spec properties of the application we defined earlier. There is no port in this example, meaning that the default value of 80,000, or no, not 80,000, 8080 will be used. So let's apply it and retrieve all applications. Look at it. That's brilliant. We can see that the silly demo was synced and that it is now active. It would be nice if we could have defined additional print columns, but that's okay. So far, I love it. Let's see the tree of that application. That's bad. It means that CRO is not adding owner references that establish relations between resources. As a result, other tools, like in this case kubecontrol tree, cannot deduce which resources created what. Still, CRO is a project in its infancy. I'm sure that will be corrected soon. Let's check what it created the old-fashioned way by listing all the resources in the A-team namespace. We can see that it did what it's supposed to do. It created the service and the deployment, which in turn created the replica set, which created the pods. So far, CRO is it's amazing. It's easy, it's simple, I love it. We're about to add ingress to the mix, but there is a slight complication. It needs to be optional, since some applications might need to be accessible from outside the cluster while others are not. To do that, we'll add ingress enabled boolean to the schema and use it to deduce whether ingress should be composed or not. While at it, we'll also add ingress host parameter that will allow users to specify the host through which their app should be exposed. Here's the next iteration of the resource group that includes those changes. We added ingress parameter with subparameters enabled and host. Apart from doing nested parameters, there is nothing new over there. Further on, we added a new resource which is also following the same pattern like the previous two. The only new instruction we are adding is include when, which will result in that resource being composed only if ingress enable parameter is set to true. I have a complaint here. The include when instruction is not documented in CRO docs. It's featured in one of the examples and it is certainly present in the code, but it's not explained anywhere how it works or that it even exists. Still, it's a new project and new projects tend to focus on code and leave the documentation somewhat forgotten. Given how green the project is, we can forgive the maintainers on not focusing on the docs, at least for now. Now, while I can ignore missing information in the docs, I cannot ignore attempts to convert YAML into something it is not. I'm fully on board using cell as YAML values, but I really do not like the idea of using YAML to implement conditionals, loops, and other similar imperative constructs. If those are needed, and in this case they are, we should be looking into using something other than YAML. KCL, Q, Go templating, YTT, or any other similar language or templating engine would be a better choice. Even generic languages like Python, TypeScript, or Go would be better choices. Don't get me wrong, I'm not against using YAML. I love the idea of using cell as values. However, I'm completely against adding conditionals, loops, and other imperative constructs into YAML. That inevitably leads into an abomination, since that puts CRO on a path of adding an infinite number of such constructs. This is the first thing I truly do not like. All other negative things I saw so far are minor and can be attributed to CRO being a very young project in very early stages. Those can be improved over time. The choice of adding imperative logic as YAML is an architectural choice that is hard to undo. Still, I will ignore that for now, so let's continue by applying the new iteration of the resource group and retrieving resource groups from the A-team namespace. We can see that the topological order now shows ingress as one of the resources that will be composed. We extended the number of resources that will be gathered, put together. And that's great, that's amazing. Okay, now let's remove the application and create a new one based on the new resource group. It will probably take a bit of time until all the resources are removed. So, patience. I'm waiting and waiting and waiting, and it seems that it got stuck. And that's very disappointing. I probably did something wrong. So let's stop the delete process and take a look at crawl logs. It seems it got confused with the ingress host key, and that's very worrying since we are not yet trying to create a new application resource, but only to delete the ones we were running since before we updated the resource group. That inability to delete the application resource and all the child resources it spun up points to the problem I mentioned earlier. It seems that it is not tracking which resources are spun up by the root resource, but blindly trying to delete resources it composed. I might be wrong. It might be something else. At the end of the day, it does not matter. What matters is that it got confused, and now we cannot even delete the root resource. And that's very disappointing. Still, it's okay. It's a new project, so let's not get disappointed just yet. I'm sure that will be fixed soon as well. In the meantime, let's delete the whole namespace. I'm waiting. That does not seem to work, and I suspect we need to remove application finalizers to progress. So let's stop the deletion and apply a patch that will remove the finalizers. Okay, now the whole namespace and everything inside it is gone, and we can move as if nothing happened. So let's create the A-team namespace again, then apply the last version of the resource group, and apply our silly demo application. We should be at the same state as we were before, except that the crawl resource group now includes ingress. Bear in mind that the application definition is still the same. We did not yet enable ingress. Since ingress is disabled by default in the resource group, the end result should be exactly the same as before. So let's check the application in the A-team namespace, and that's very disappointing. Something is not working since the synced column is empty. That probably means not only that it was not synced, but that crawl got completely confused. I suspect that it did not compose any resources, but let's check it out just in case. Yep, there is nothing there. Now, let's assume that we, or to be more precise, I, did something wrong. Events in the application should give us a clue as to what's going on. My personal state of mind is getting converted from disappointment to frustration. Events are a cornerstone of debugging issues with Kubernetes resources, and there is nothing over there. Someone forgot to implement events in the crawl controller. To make things even worse, there are no statuses either. It is literally doing nothing and showing no signs of life. Let's see whether we can deduce what's going on from the resource group itself. If you take a look at the status conditions, everything seems to be working correctly, even though it's obvious that it's not. The events are nowhere to be seen, and my frustration is growing. I'm boiling. Let's do one more check before we give up on it by taking a look at the logs. There's the problem. It is trying to evaluate ingress host key, and that's failing because we did not specify ingress in the application. Still, that should not be an issue for multiple reasons. First of all, the whole ingress resource should not be composed if ingress enabled is not set to true. We did that through the include when instruction. Furthermore, we defined that it is set in the schema to false by default. So, if we do not specify ingress enable field in our composite resources, crawl should simply not compose ingress. That's the point of it. That's the intention. Now, to be fair, there is always a chance that I did something wrong. I doubt that's the case, but even if it is, crawl should be a bit more helpful, pointing us to the origin of the issue. Not to mention that docs do not provide any clue as to what to do in a case like this one. Still, this is a young project. I expect it to have issues. So let's ignore this and assume that it will be polished with time. Today we are evaluating the idea rather than the implementation. If crawl gets confused when we don't specify ingress in our custom resource and ignores default values in the schema, let's fix the issue with the modified version of our application. The difference is that this time we are setting ingress enable to true and defining the ingress host. So let's apply the updated definition and list all the applications in the A-team namespace. This time it seems to be working correctly. We can double check that by retrieving all the core Kubernetes resources and ingresses. That's it. It's working. Now we are getting not only service and deployment, but also ingress resources composed through crawl. Now that ingress is in the mix, we should be able to send requests to our application and get the "this is a silly demo" response. That's brilliant. We made it work somehow. We would still need to figure out how to overcome the situation when we do not want to have ingress, but I'll leave that for some later time. Right now, we are going to move into adding the database to the mix. There are 3 things we will try to add. First, we should be able to optionally add CMPG Postgres that should be applied only if a user chooses to enable the database. Second, we should add also optional schema management with the Atlas operator. Finally, we should enhance our deployment so that our application gets the information how to connect to the database as environment variables generated from the secret CMPG will create for us. Let's start with the last task by adding the environment variables that should appear only if the consumer chooses to enable database usage. Here's the updated definition of the resource group. We made changes to the schema by adding DB-enabled property that defaults to false. That way, database usage is opt-in. Further on, we added the env section to the deployment. It provides the environment variables like DB endpoint, DB port, and address required for the application to connect and authenticate to the database. But we have a problem though. The include when statement, as far as I could figure by reading the code, since the documentation does not even mention it, works only on the resource level. We can choose which resources to exclude when composing resources, but we cannot decide which parts of resources to exclude. This is yet another proof that YAML is not a good choice for anything but very simple scenarios. As it is now, those variables will be fetched from the secret with database credentials no matter whether we enable database usage or not. As a result, we would have to always have the database. Otherwise, the pods created through that deployment would end up in an infinite pending state, forever waiting for the secret to appear. Now, we'll cross that bridge later. For now, let's apply the updated definition of the resource group before we move on and add CMPG to the mix. Now, I expect that the change to the resource group will result in changes to all resources it manages, right? I expect that the addition of environment variables to the composed deployments should have been performed. Let's check that out by outputting the existing deployment that resource group created earlier. The env section is nowhere to be found. The deployment is exactly the same as it was. The changes to the resource group were not propagated to the resources that are already in the cluster. That's bad, since that means that every time we improve our resource groups without changing the API version, we need to delete and create all the instances of it. That's silly. Still, I'm keeping my excitement high. I love the idea of CRO, and I will blame this on it being a project in its infancy. I'm sure that it will be improved soon. So let's delete the application against my will and apply it again. Let's see whether it works now. So changes to resource groups are not automatically propagated to instances of it. We had to delete our application and create it again to make it work. That's unacceptable. That's really unacceptable, but I will overlook it, assuming that it will be fixed in one of the next releases of Chrome. We are left with 2 pending tasks. We should add the CMPG cluster resource that will be creating PostgreSQL database and the Atlas operator resources that will handle database schemas. Let's do CMPG first. Here's the updated resource group. This time we did not change the schema. The only thing we are doing is adding one more resource with the ID PostgreSQL. It is a CMPG cluster and there is nothing, and I repeat, nothing special about it. It's following the same pattern as the ingress resource we added earlier with the include when set to include it only if DB enabled is set to true. This was an easy one, so let's just apply it and retrieve all resource groups from the A-team namespace. What the? Okay. Calm down. As soon as I think that we're out of woods, or to be more precise, as soon as we start ignoring one issue, another one appears out of nowhere. This change made the resource group state inactive. What the heck is the problem now? We haven't done anything new. We added a resource using the same patterns and the same constructs, as the resources we added earlier. I just did a bit more of the same. Let's hope that this time we'll see what's wrong by describing the resource group. Hopefully it will not be like the last time when it claimed that everything works correctly, only to discover that it stopped working altogether. We can see that it failed to generate dummy CR. I have no idea what it means, and frankly, I would not know what to do to fix it. I know for certain that the resource definition of the CMPG cluster works correctly. That I know for sure. I know that it works when applied without CRO resource group. So, I give up for now. CRO is not yet ready for prime. And that's okay. It's a new project. Having a bunch of issues is normal. At this stage, it is the idea that matters. And the idea is... Let's talk about the idea behind CRO. I have a very important question to ask you. Here's the big question. Why? Why was CRO created? We already have projects that allow us to create custom resource definitions and compose resources when custom resources based on those definitions are created. That's what KubeVela does. That's what Crossplane compositions are for. There are other projects that serve a similar purpose. So, why was CRO created? Before I tried the project, I was certain that CRO was born because its authors came up with a better way to compose resources. I was sure that the authors saw what Crossplane compositions are doing. As a matter of fact, I saw in the early commits that they were inspired by Crossplane compositions. So, they must have come up with a better way to compose resources. However, I don't see what that better way is. Crossplane composition started as YAML only, just as CRO is now. CRO's syntax is arguably a bit easier and with less boilerplate code, but that's to be expected since it offers only a fraction of the features Crossplane provides. Cell is a good choice for simple scenarios, but Crossplane now supports functions that allow it to compose resources using any language. Arguably, Cell is not one of the languages currently supported, but that would be fairly easy to add. The only tangible benefit I see with CRO is that everything is namespace scoped, while Crossplane resources, excluding claims, are cluster scoped. Crossplane 2.0 is planning to change that, and CRO folks might not be aware of that plan. Still, is that the reason good enough to start a new project that does a fraction of what Crossplane compositions do? Could it be that CRO authors think that Crossplane is a bad choice? That could be it. Crossplane is certainly not for everyone. Nothing is. Still, there is KubeVela and there are other similar projects that already do what CRO does. Just better. All in all, I don't have an answer to the simple question. Why? Why was CRO created? What is the mission of the project? What does it try to do that hasn't been done before? At the same time, CRO is going through the same phases as other projects went through. It's green, just as Crossplane compositions were green years ago. It's missing features, and it's buggy, just as Crossplane was missing features and was buggy years ago. CRO started as YAML only, with cell values, and is bound to end up with an abomination as the need for imperative constructs emerges, like, as we saw before, the need for conditional statements applied in parts of resources, or loops, and whatever else. The alternative to becoming a YAML abomination is to extend itself to other languages, just as Crossplane did years ago. All in all, CRO is serving more or less the same function as other tools created a while ago, without any compelling improvement. If anything, it is likely going to end up going through the same stages as other projects went. I wanted to see it being radically different or having a different mission or solving the problem in a different way. And that's not the case. Or maybe, or more likely, I'm failing to see it. So, my question still stands. Why? Why was CRO created? I'm all for new projects that solve new problems or are trying to solve problems that are already solved in a better way. I just don't see CRO being one of them. I hope I'm wrong. I honestly do. Actually, I'm sure I'm wrong. I'm sure that CRO authors have a good reason why the project was created and that they just did not get to document those reasons or that reason just yet. I will get back to the project in a few months, maybe half a year, and by then I am sure that the light bulb will turn on in my head and I will say, now I get it. Until then, thank you for watching. See you in the next one. Cheers.